Okay, so hi guys and good morning. Once again, this is MJ Bautista and I will be sharing with you another discussion about Newton's law of motion. So we're going to discuss this in relation to our biomechanics subject, and this will be for our weeks 2 and 3 session. So I'll be going to discuss with you more about the Newton's law of motion. So I know that you're already familiar with this because these are subjects that are mostly used by physics on your physics subject during your secondary school days. So topics 1, 2, and 3. So the law of inertia, and then the force is equivalent to mass times the acceleration, and the action, that is the reaction. So going further, while most people know what Newton's law says, so many people do not know what they mean or simply do not believe what they mean. Okay, so it's because that they don't know further about this specific ideas. Now, in the Newton's law of motion, for the first law, an object at rest, no, meaning not moving, will stay at rest, and an object in motion will stay in motion. So the first law is, if you're going to put your cell phone on the floor, or if you're going to put your cell phone on the table, it will be there forever. Okay, so unless you're going to exert an effort, you're going to put a force, then therefore there will be a movement. And an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. And then the second law of motion is the force equals mass times the acceleration. So the third law is, for every action there is an equal and opposite reaction. Okay, so the first law of motion is the law of inertia. So an object at rest will stay at rest. Even if you're not going to move it, it will stay there forever. And an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. So we're going to go further with this. The first law, the inertia, is the tendency of an object to resist changes in its velocity, whether in motion or motionless. Like for example, these pumpkins will not move unless acted on by an unbalanced force. Okay, so when you say velocity is equivalent to a specification of an object's speed and the direction of motion. Now, the first law, once airborne, unless acted on by an unbalanced force, the gravity, air, fluid, friction, it will never stop. Okay, so as what you can see here, there's a golf ball. Then there's a certain force that is being applied. That's why this ball is now moving. So unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. So if you're not going to move it, if you're not going to exert an effort, so therefore this golf ball will stay here forever. So why then we observe everyday objects in motion slowing down and becoming motionless, seemingly without an outside force? It's a force we sometimes cannot see, or what we call the friction. So objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. So what is the unbalanced force that acts on an object in motion? So that's what you call friction. So there are 4 main types of friction. Number 1 is the sliding friction. Okay, so once there's a slippery motion, there is an unbalanced floor. So there's a tendency for an object that goes to a sliding motion because of the forces of gravity. Then the rolling friction, like for example, when you're going to roll the ball, so that is an example of a friction. And then fluid friction, air or fluid, air or water resistance, and the static friction, initial friction when moving an object. And then slide a book. This is an example of movement. Slide a book across a table and watch it slide to a rest position. So there's always, once you're going to move an object, there's also a tendency for it to stop for a certain period of time is because of the amount of speed or force that is applied to a certain object. So the book comes at rest because of the presence of force. Whenever the force is applied after the application of force, so of course the object will stop. So which brings the book to a rest position. So next one, in the absence of a force of friction, the book would continue in motion with the same speed and direction forever, or at least at the end of the timetable. So not only with the force, because friction also adds the speed of a certain movement or action. So Newton's first law and you. So don't let this be you. Wear seatbelts. Okay, so that's why this is a very good example. If you're not using your seatbelt, so there's a tendency for this object to move. So yun. If you want to prevent from accident, of course, when there is this blue car is being when you bump into a certain object, of course there is the force. Then of course, if you're not using the seatbelt, there is really a tendency for you to fly over it. So because of inertia, objects including you resist changes in their motion. So when the car goes to 80 kilometers per hour and stopped by the brick wall, your body keeps moving at 80 meters per hour. So will you imagine that? So next, the second law, this is the formula in order for us to know how much force are we going to exert. M stands for mass times A is for acceleration. So later, we're going to compute this, how we're going to get a certain force, and then the Newton's law. Second law, the net force of an object is equal to the product of its mass and acceleration, or F equals to ma, or the force equals to mass times acceleration. So this second law, when mass, the unit of measurement, when mass is in kilograms and acceleration in mass over seconds per second, so the unit of force is in newtons. N, the letter N stands for Newton. So 1 Newton is equivalent to the force required to acceleration 1 kilogram of mass at meters per second per second. So the second law formula is force is equals to mass times acceleration. So how much force is needed to acceleration? A 1,400 kilograms car, 2 meters per second per second. So what is the formula? Force equals to mass times acceleration. Fill in the given numbers and units. So force, or the Newton formula, is equivalent to 1,400 kilograms. So that stands for the mass or the weight of the object times the meter or the acceleration. So the meters, 2 meters per second per squared. So what you need to do here is just to mass times the acceleration. So 2,800 times 2, which is 2 meters, that will give you an equivalent of Newton force of 2,800. So now let's try this, and I hope you're going to comment down below what's your answer for net force 20 and mass kilogram of 1. So example, the answer for a mass kilogram of 2 kilograms and the acceleration is in 5 meters per second. So 2 times 5, that will give you to a net force of 10. And then 2 times 10, that will give you a net force of 20. And then so try to solve this. What is, if the net force is 20, what is the mass kilograms if the acceleration is in 5 meters per second per second? Then number 2, what is the acceleration number unit if your net force is 10 and the mass kilogram is 5? And number 3, what is the net force if your mass kilograms is 1 and your acceleration is 10? So if mass remains constant, doubling the acceleration doubles the force. If force remains constant, doubling the mass halves the acceleration. So Newton's second law proves that different masses accelerates to Earth at the same goal, but with different forces. Of course, if the mass differs from one to another, because it depends. The higher the mass, the higher the force is needed, or an equivalent force is needed in order for that object to move. So we know that objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know that they don't hit the ground with the same force. So like for example here, the force equivalent to MA, so 98 Newton, this is the force, and then if your mass kilogram is 10 kilograms times 9.8 meters per seconds per square. So your force is 98 newtons. So we are going to apply the Newton's second law. Like for example, if you have a 1 kilogram mass times 9.8 meters per seconds per squared acceleration, so your force is 9.8 newtons. So even if you came up with the same acceleration unit, 9.8 equal to the other kilogram or the mass, so even though they have the same, but still the force exerted will never be the same. It's because of the amount of mass that is expressed in kilograms. So for the first one, for the 98 newtons force, there's a heavy object that is 10 kilograms, and for the second one is only 9.8 force, which is only 1 kilogram. So the lower the mass, the lower the force, the higher the force, the higher the mass. So next, check your understanding. I want you to try this. What acceleration will result when a 12 Newton net force applied at a 3 kilogram object? So what if your object is 6 kilograms? And number 2, a net force of 16 causes a mass accelerates at the rate of 5. Determine the mass. How much force is needed to accelerate a 66 kilograms skier 1 meter? The acceleration is 1 meter per second. And number 4, what is the force on a 1,000 kilogram elevator that is falling freely at 9.8 meters per second? Okay, so I'm not going to show you the answer, but I hope that you're going to try this and you can comment down below your answers. So force is push or pull, right? So that causes the changes in motion of an object. So there's this gravity, the force between an object, and of course the static energy, electricity, which is the electricity or the force of electrons. Then there's this also what we call the other force, which is the magnetism, the force of the field. And then the last one is the friction. Friction, the force opposing the motion. Moving further is a third law. For every action, there is an equal and opposite reaction. Okay, so these third laws, according to Newton, whenever object A and B interact with each other, they exert forces upon each other, right? Okay, so when you sit in your chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. And then the third law, there are two forces resulting from this interaction, a force on the chair and the force on your body. So these two forces are called action and reaction. Okay, so since the chair has that stability, so therefore the force being exerted is what you call the action and reaction forces. Well, the Newton's third law in nature. So consider the propulsion of a fish through a water. A fish uses its fins to push water backwards. In turn, the water reacts by pushing the fish forward, propelling the fish through the water. So the size of the force on the water equals the size of the force on the fish. So the direction of the force on the water backwards is opposite the direction of the force on the fish, which is forwards. So the third law also in nature, this is also an example of a beagle or a bird flying gracefully through the air. The birds depends on Newton's third law. So as the birds push down the air, their wings, and the air pushes their wings up and gives them a lift. So that's why they keep on flying. So consider the flying motion of bird. A bird flies by using its wings. So the wings of the bird pushes the air downwards. In return, the air reacts by pushing the bird upward. So the size of the force on the air equals the size of the force on the bird. The direction of the force on the air downwards is opposite the direction of the force of the bird upwards. So action-reaction, force pairs make it possible for birds to fly. Okay, so next, other examples of the Newton's third law. So the baseball forces the bat at the left on action. The bat forces the ball to the right, or the reaction. So consider the motion of the car on the way to the school. A car is equipped with wheels which spins backwards. As the wheels spins backward, they grip the road and push the road backwards. So there's this movement. Another, for the third law, the reaction of rocket is an application of the third law of motion. So various fuels are burned in the engine, producing hot gases. So the hot gases push against the inside tube of the rock and escapes out the bottom of the tube. As the gases move downward, the rocket moves in an opposite direction. Okay, so that's it, guys. I have already instructed you in how we're going to analyze and understand more about the Newton's law of motion, the first, second, and third law. And I hope that you're going to apply this in some of the basic movements in terms of physical activity and sports. So once again, guys, thank you so much, and I hope that you enjoyed my short video presentation. Goodbye and see you next time.